Okay, so let's pretend we start off with 2 red balls and 3 black balls. So we have a total of 5 black balls at the beginning. Our first event is we draw a ball. So out of this, if we draw a red ball, we drew a red ball. What do we have left in our list? We have 1 more red and 3 blacks. That's if we drew a red. If we drew a black ball, what do we have left from the beginning?
2 red and 2 black.
Yes. Because there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. The second event, we do the same thing. We draw a ball. Now, out of this list, I could either draw a red. If I drew a red, what do I have left?
3 black.
Yeah, I have no more reds and I have 3 blacks. Because at the beginning, I had 5 balls. I drew a ball, so I only have 4 balls left. I drew another ball, I have 3 balls left. So that's if in this one, if I drew a red. What if from here I drew a black? What do I have left there?
1 red and 2 black.
Perfect. Because we have to have 3 balls left. Now, how about this side? If we drew a red, we had 2 and 2. If we drew a red, what do we have left?
1 red and 2 black. Yeah.
Perfect. Or if we, from this one, we drew a black.
2 red and 1 black.
Excellent. So that's the second event. Let's look at the third event. Same thing. Because at each one of these, we could either draw a red, or if we drew a red from this one, can we draw a red from this one?
No.
No, because there's no more. That's impossible. So it's 0. How about in this one? Oh,
1
can we
red
draw?
and-
Can we draw a black from this one?
Yes, 3.
Yeah. So that leaves us with 2 blacks left.
Oh, yes.
Now in this one, can we draw a red?
Yes.
Yeah. If we drew the red, all we have left are 2 blacks. If we drew a black on the second one,
1 red and 1 black.
perfect. How about this one? If we drew a red on the next one,
Would just leave us with 2 black.
okay. If we drew a black,
It'll leave us with the red and 1 black.
very good. If that was a red,
1 red and 1 black.
and a black,
2 reds and
and
no
no
black.
blacks.
How do we know when to keep going? Like, we're on the third event. Is it when all of them are 0?
Well, no.
Or
It would tell you how many balls you're going to draw.
and that's how we would that's how
Right.
we'll know when to stop. Okay.
Because we know we can't go any further. Because what if I wanted? Can I have 3 red balls? No, because there's only 2. So it would. The question will tell you how many times you draw. So that's how you create the chart. Now, each one of these have their own probabilities. From the beginning to this one. At the beginning, we have 2 reds and 3 blacks. So the reds, there are 2 possibilities out of 5. Those are the reds. And the blacks, 3 out of 5. Those are the blacks. So after the first event, we drew a color. Now we only have four things left. What's the probability of getting a red out of this list?
1 out of 4.
Yep. What's the probability of getting a black from this list?
3 out of 4.
Very good. How about this one? What's the probability of getting a red?
2 out of 4.
Right. And probably getting a black?
2 out of 4.
Yeah. And if you look at these things, these are very important. At each level, if we take 2/5 plus 3/5, what does that equal?
1.
Mm-hmm. How about this one? 1/4 plus 3/4 equals
1.
2/4 plus 2/4.
Also 1.
Also, so at each level, your probabilities have to equal 1. Okay, now this is the next level, third level. What's the probability? Well, you can't get a red, so the probability is 0. What's the probability of getting a black on the next level?
2.
No, there's
Oh, 3.
3 out of 3. It's 100%. Because if we had red and red, all we have left in our bucket is black balls. So we're gonna, if we drew another ball, it has to be black. So that's where we're gonna be 100%. So if we reach in the bucket, got a red ball, then a black ball, what's the probability of getting a red ball?
1 out of 3.
1 out of 3. And getting a black ball?
Oh, 2 out of
2 out of 3. Yeah, because 1/3 plus 2/3 equals 1. And how about this one? You drew a black ball, then a red ball. What's the chance of getting another red ball?
1 out of 3.
Very good. There's only 1 out of 3. You got a black ball, a red ball. What's the chance of getting another black ball?
2 out of 3.
Right. 2/3 plus 1/3 equals 1. You got a black ball, a black ball. What's the chance of getting a red ball now?
2 out of 3.
Perfect. What's the chance of getting 3 black balls?
Can you? If there's only 2.
There's 1 left. There's 1 black ball left.
Oh,
1 out of 3. Plus 2/3 plus 1/3 equals 1. So now, once you create the table, if I ask you, what's the probability of getting 2 blacks and 1 red?
oh, 2 over 4.
Now we have to look at this, because at each level, the probabilities change. So what we have to look for here is the probability of getting a black, probability of getting a black, the probability of getting a red, or the probability of getting a black, probability of getting a red, or we have to look at all possibilities. Because all it said, I want 2 blacks and 1 red. Didn't say any order. So I have 2 blacks and 1 red, 2 blacks and 1 red, 2 blacks and 1 red. So let's look at this. What this one says, the first one's a black, which is 3/5. The next one's a black, which is 2/4. And the last one's a red, which is 2/3. You see how I got that?
Mhm.
You look at each one of these. At the first one, the first event, the probability of getting a black is 3/5. The next one, getting a black, is 2/4. And then the next one has to be a red. That one is 2/3. We'll work on that one. How about this one? If we get a black in the first one, that's 3/5. Then we get a red, which is 2/4. And then we get a black, which is 2/3. Or how about this one? We do a red, which is 2/5. We do a red, that's the first red. Then we do a black, which is 3/4. Then we do another black, which is 2/3.
How do you know which fraction to use?
But that's what this says. This is the first event,
Oh,
second, and third. So in the first event, I got a black. So I had to go here.
Can you move the paper down a little bit?
Yes.
Okay.
So on this top one, it says probability of a black. So it means in the first event, what's the probability of getting a black? 3/5. That's that one, 3/5.
Oh, okay.
Now, from that one, I'm going to go back to another black. So I go from black to black. That one's 2/4. And then I go from black to red. So each one tells me I have to go to this one, then this one, and look at the probabilities. Like even this one here, red, black, black. If I go to a red first, that's 2/5. Then from this red, I have to go to a black, which is 3/4. And then I do another black, which is 2/3. So this just tells you which numbers to use. Now, if you look at all these, whenever you multiply fractions, always reduce first. The 3's cancel. 2 goes into 4 twice. 2 goes into 2 once. So we have 1/5. Next one, we have the 3's cancel. The 2 times 2 is 4. That cancels. So it's 1/5. 3's cancel. 2 times 2 is 4. That cancels. So it's 1/5. So it doesn't matter how you do it. It's always going to give you the same answer.
Oh, okay.
So the probability is 1 out of every 5 times we try to get 3 colors. It's going to be 2 blacks and 1 red in any order.
Can we do
Yes, this is
number 1 again? Like the way
yes.
with the tree.
Yes.
The same.
Okay, I mean,
Just so I can see.
switch screens. Okay. It says a box contains 4 white and 3 black. Complete parts A and B below. Part A ball is drawn at random from the box and not replaced. Again, whenever you do drawing, taking something out, it has to tell you whether you put it back or you don't put it back. Because if you don't put it back, it changes the odds. So 1 ball is drawn at random. Then a second ball is drawn at random from the box. Draw a tree diagram for this experiment and find the probability of the event that the 2 balls are the same color. Okay. So far, so good?
Yeah.
All right, so let's go back to ours. So we have 4 white and 3 red. That's what we have at the beginning. So in the first one, what's the probability of drawing a white ball?
4 out of
Out of,
7.
very good, very good. What's the probability of getting a black ball on the first draw?
3 out of 7.
Perfect. Now, with replacement, so we put the balls back. Then let's look at the top part only. If our first ball drawn was a red, what's the chance that our second ball, I mean white, not red, white. What's the chance the second ball is a white?
4 out of 7.
Yeah, because we put the ball back. We drew a white ball in the first one. What's the chance the second one is a black ball?
3 out of 7.
Very good. Now let's look at the bottom. If we drew a black ball in the first one, then we drew a white ball. What's the chance of that happening?
4 out of 7.
Very good. And then if we draw a black ball, then we drew another black ball. What's the chance of that?
3 out of 7.
Okay. Now what it's looking for is what is the probabilities of getting the same ball, same color ball. So the probability of getting 2 whites or 2 blacks. Probability of 2 whites is 4/7, which is that, times 4/7, which is 16/49. The probability of getting 2 blacks. The first one is 3/7. And then the second one is also a black, which is 3/7, which is 9/49.
Would we add those?
No. This is the probability of getting 2 white balls. This is the probability of getting 2 black balls.
Oh. And this was with replacement?
With replacement, right.
Okay.
Let's see, let me switch over now. Okay, so which one is it going to be? Well, we saw in our diagram, it's 4/7, 3/7, 4/7, 3/7. So those are all good. The first one is good. Now, the second, that one's wrong because that's just going, you only have 1 ball. That one's also wrong because the second ball with replacement, we still had 4 white balls and 3 black balls. So the answer has to be C, because that looks like the picture we drew.
Yeah, okay.
So that's why I said, that's why whenever you read the question, don't look at their possible answers. Work it out first the way you think, and then we'll see that their answer matches our picture. 4/7, 4/7. That's exactly what ours looks like.
Yeah.
Okay, so check your answer. Incorrect. That is what the probabilities are,
Oh.
because it's replacement.
It's because it says not replaced. Oh wait. Yeah, isn't it without replacement? And we did with replacement.
Oh, okay. That's what you're right. It's not replaced.
So at least we like did an example for width replacement.
Good catch. I didn't catch. Very good catch. I read it too. No. So
Yeah.
this is with replacement. Okay, without replacement, I am so sorry. Good catch on your part.
No, it's okay.
So this is 4/7, 3/7. Now, we no longer have 7 balls because we had 4 white balls and 3 black balls. We drew a ball. It's a white ball. These are the white balls. So we drew a white ball. That's that one.
Mhm.
What do we have now? What's the probability of drawing a white ball in the second one?
3 out of 6.
3/6, which is 1/2.
Mhm.
And the chance of getting a black ball,
It's 3 out of 6.
which is also we simplified 1/2.
Mhm.
Okay, now on the bottom part, we had 7 balls, and the first ball we picked was a black one. So that one's gone. So what's the probability of getting a white ball now?
4 out of 6.
4/6, which is 2/3. And the chance of getting a black ball,
It's 2 out of 6.
which is 1/3. Yes.
Okay.
Which is what that says there. So it's D. If I only know how to read the questions. That's your fantastic. Okay, now the probability of the event, the 2 balls are the same color, is what?
Would we have to solve it again, or it would not change?
Well, let me see. So the probability of the event that the 2 balls are the same color. So let's see how you work that out. Okay.
Would it be 4/7 times 1/2?
Okay, what's that going to equal? So the 2 and the 4 cancel. 2 times 1 is 2. 7 times 1 is 2/7. How about the probability of both being black?
3/7 times 1/3.
The 3's cancel. So then we have 1/7.
Yeah. Okay.
Okay, now in this one, okay, this is where the question itself becomes tricky. The probability of the event that the 2 balls are the same color. It doesn't specify which one. So what we have to do, the probability of getting both of them being white, the probability of both of them being black, the probability both the same color is they're both probably going to be white, or they're both going to be black. So that's 2/7. The word or means plus. Because this is the probability of both of them being white. Now, The question is here, why is this multiplication and would this one be or, be plus?
Mm,
Same color, that means the probability of the first one has to be white and the second one has to be white. Because of the word and, that means multiplication. If I said if the first one's white then or the second one's black, if they're different colors, then it'd be an or. So an or means plus, an and means multiply.
mhm.
So the probability of both of them being the same color. So the probability of being a white is 2/7. The probability of being a black is 1/7. If we add them together, we get 3/7.
Okay.
3 divided by 7. Okay, so now you see that. So each one of these back to back, those are multiplied. But now at the very end, if I want to choose any one of those, then I have to add those probabilities.
Okay.
Let's look at the next one. Oh, there's part B. Suppose that the ball drawn at random from the box, its color is recorded, and then the ball is put back. Okay. The second ball is drawn. Try it. This is now since we put the ball back, that's what we did originally.
Yeah.
And that's going to be this one.
Mhm.
Hold it. I have to get this phone call. Hold on.
Okay.
Great. Yourself? So with replacement, the chance of getting a white ball never changes because we put the ball back. The chance of getting a black ball never changes. So it's 3/7, 3/7, 3/7 for black, 4/7, 4/7, 4/7 for white. So that one has to be that one.
Mhm.
Now, what this one's going to ask, what's the probability of getting two balls the same color? Remember how we did that earlier?
That'd be that's when we got 16/49 and 9/49.
Yes, because for the whites, it's 4/7 times 4/7 because it's the same colors. The first one and the second one have to be the same color.
Mhm.
So it's 4/7, which is 16/49, and then 9/49. So what do you do with those numbers?
You add them.
That gives us what?
25
Over.
98. Oh.
Because the bottom numbers are, since the bottom numbers are the same, we just
Oh
use
yeah.
those.
Okay.
You were so close. But you get it well done.
Okay.
Yeah, so whenever you're adding them, if the bottom numbers are the same, just leave them that way.
Okay.
Okay, number 2. A box contains 8 letters showing crashing. What is the probability of the outcome gain in that order if 4 letters are drawn one by one with replacement and without replacement? Okay. So this is what this is saying. This is number 2. We have 8 letters, CRASHING, and we choose 4 letters. What is the probability of them coming out in this particular order, with and without replacement? So what we have to look at here is this: the probability of the first letter being G. Then the next one, the probability of that one has to be A. Then the third letter has to be an I, and then the fourth letter has to be N. So what's the probability of getting a G on the first draw?
A 1 out of 8.
Okay, we put it back. Chance of getting an A,
1 out of 8.
an I,
1 out of 8.
and an N.
1 out of 8.
So because the G has to be first and the A has to be second, and since the word is and, we multiply them.
Okay.
So 1 times 1 times 1 times 1 is 1. 8 times 8 times 8 times 8 is 8 to the 4th. What is that?
32.
No,
Oh,
is
8 to the
it's
4th.
8 times 8, 64. 64 times, so it's going to be,
Oh, we're gonna,
we
okay.
have to multiply 8 3 times. So it's 8 times 8 times 8 times 8. It's 1/4096. Because we have to multiply all those together.
Okay.
So it's 1/4096. Continue. Okay, now without replacement. The same thing. We have to get the probability of getting a G in the first one, an A in the second, an I in the third, an N in the fourth. So what's the probability of getting a G?
1/8.
Okay, probably getting an A.
1/7.
Excellent. Next one.
1/6.
Very good.
1/5.
So it's 1 over
Oh,
so
we have to
6 times
multiply all.
5 is 30. 30 times 8 is 240. 240 times 7, 1680. I better check. I hate to get a not perfect. $16.80. So it's 1/1680. Well done. Okay, number 3. A executive committee consisting of 10 members, 4 men and 6 women. 3 members are selected at random to attend the meeting in Hawaii. The names are drawn from a hat. What is the probability that all 3 selected are men? So 10 members, 4 men, 6 women, 3 selected. Probability, all 3 are M's. So how do you think this has to get done?
Like the we're gonna have to use fractions again.
Yeah, probability always deals with fractions. So you have 3 people. The first one's a man. The next one is a man. And the third one is a man. And they all have to be multiplied because they all 3 have to be men. The first one and the second and the third. Now, is this with or without replacement?
I don't remember.
Well, if you're picking people from a list,
Oh, it's without.
yeah, because they're picking them out of the list, so it's without. So what's the probability of the first one being a man?
4 out of 10.
Next one?
4 out of 9.
3
3 out of 9.
out of 9. Yeah, because one of your men from this list is gone and one of these members is gone. So it's 3 out of 9. Okay, so now what's the last one chance of being a man?
2 out of 8.
Perfect. So you notice as you remove them, it goes down 1.
Mhm.
So let's see, the 3 and the 9 cancel. The 4 times 2 is 8, that cancels. So it's 1 times 1 times 1. 10 times 3 is 30. 1 over 30. Now the rest of them are pretty much be the same way. It's using the same type of logic.
This one was another question that I didn't understand.
Okay. Assume the probability is 1/2 that a child born at any time is a boy and births are independent. Okay, now we're talking about independent versus dependent. What is the probability of the event that if a family has 3 children, not twins, none of them is a boy? Okay, so the probability of getting a boy is 1/2. Now, what does it mean when it says independent?
Um, that they happen separately.
Yeah, actually, it's a very good answer. Because if it's independent, one event does not influence another. So the occurrence of one event does not influence the occurrence of another event. So now we have to look at this. If the probability of getting a boy is 1/2, what's the probability of getting a girl?
1/2.
Yep. How do we get 1/2?
Out of you can either get a boy or a girl.
Yeah.
One could be.
Because the probability of getting a boy plus the probability of getting a girl has to equal 1, because that's all. It's either boy or girl. And if boys are 1/2, we don't know what girls. So we subtract.
Oh,
If we subtract 1/2 from both sides, 1 minus 1/2 is 1/2. So the probability of getting a girl is 1/2. That's how we do it. Because of this rule, the summation of all probabilities has to equal 1. So therefore, if we had 3 children and there were no boys, that means the first one was a girl, the second one was a girl, and the third one was a girl. 1/2, 1/2, 1/2. 1 times 1 times 1, 2 times 2 times 2, 1/8. Okay, and I'm gonna show you how this relates to that table we did earlier.
okay.
Well done. Okay, let's look how this relates to the table we did earlier. Okay. There's a family. They have a baby. Probability of the first one is a boy. That's 1/2. Or the probability of the first one being a girl is also 1/2. That's the first child.
Mhm.
The second child, if the first one was a boy, the next one can be either a boy or a girl. Since they're independent, the probabilities are still the same. If the first one was a girl, the next one can be a boy or a girl. And again, the probability is 1/2. That's the second event. That's the second child. The third, the baby being born could be a boy or a girl. 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 That's the third child. So far, so good?
Mhm.
Now, what they said is, what's the probability of getting all 3 girls? Of getting a girl, getting a girl, and getting a girl. This is the only one where all 3 are girls.
Okay.
This one up here, a boy, boy, boy. This is boy, boy, girl. 2 boys, 1 girl. Boy, girl, boy. 2 boys, 1 girl. Boy, girl, girl. 1 boy, 2 girls. Girl, boy, boy. Girl, boy, girl. And girl, girl, boy. How many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. And only one of them is all girls.
Okay.
So that's how you use charts. And then again, each one of these probabilities, 1/2 times 1/2 times 1/2 is 1/8. So you could do it either way. And if you look at this, 2 boys, 1 girls, 2 boys, 1 girls. There are 3 out of 8 of those. 1 boys, 2 girls. 3 out of 8. 1 boy, 2 girls. 2 boys, 1 girl. Remember I said earlier, if we look at all the probabilities, they have to equal 1. So all boys plus all girls, 2 boys, 1 girl, 1 boy, 2 girls. Eight is a common denominator. 3 plus 3 is 6, 7, 8. It has to equal 1.
Mhm.
So that's not going to check if that's a fair distribution.
Okay, I'm starting to get it.
Yeah,
more.
yeah. If you get stuck, just try drawing a picture and see where it takes you.
Yeah.
Yeah, so try the rest of them yourself. And if you get stuck, then we can always do this again.
Okay.
So you feeling a little better than you did earlier?
Yeah, I was getting really frustrated because I was trying to just get ahead, but I couldn't because I didn't understand it.
I know, especially when you started chapter 9, section 1, and you get stuck in 2. So yeah,
Yeah.
and that's why the first class, the 1350 course, starts leading the way for all this stuff. It works through the basic math stuffs.
Mhm.
So, but no, if you get stuck again, just send me another message and we'll coordinate a Zoom time.
Okay. Thank you. This
You are
helped.
very welcome. And do you want me to send this to you?
Yes.